froze. There we go. There we go. Now that my screen's not frozen. So again, we're done with logs and exponentials and all that jazz. We're gonna go into, today we're gonna focus on factoring for a hot minute. And then we're gonna go into our new kind of function tomorrow, which we will use factoring pretty much every day of this next chapter. So it's really, 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 really important we remember how to factor. Because we're going to use it before spring break and we're going to use it after spring break. This chapter does split across spring break, so we're going to do notes for about a week, and then we're going to take a quiz next Wednesday before spring break. After spring break, we'll finish things up with like graphing and stuff, so it's going to be like 2 quizzes, but split across spring break. This one, it fits really well. There's a really good break in the concept across spring break, so it's not like going to be super hard to remember across spring break. It'll be all right. But it's really, really, really super important that we remember how to factor. So that's what we're going to work through today. Looking at this bell work here. What is a pair of numbers that adds to be 1 and multiplies to be negative 20? Negative 4 and positive 5. That's what we're looking for, a pair of numbers. So a pair of numbers that adds to be 11 and multiplies to be 18. 2 and 9. 2 and 9. Going to enunciate carefully because it sounded like I said 2, 1, 9. This stuff is going to come up. It's really, really important that we practice this stuff. So hopefully you picked up with the bell work that other page that was over there, because that's going to be our notes for today. And it's really, really, really going to walk us through factoring. Y'all have factored before. We did it last semester with our quadratics. You did it in Algebra 1 for about a whole chapter. So that's where we're taking our standard form, which you can see our standard form up on the poster behind me. Our ax squared. Hang on, I am using the wrong pen. I'm like, that feels super chunky. Because it is. Ax squared plus bx plus c. Which one's A, B, and C will make a difference. What is, for this question number 1 here, what is our A value? A is 1. What is our B value? Negative 6. And what is C? 8. There are other ways of factoring than the X in box. There's a split the middle, there's a bottoms up, there's a factoring by grouping. There are several different ways to do it. I feel like the X in boxes covers a lot of the pieces. So if you use the other methods, you wind up with the same pieces as X in box. X in box is very visually easy to follow, even if you're using another method. So I tend to use X in box. It's also the one we tend to teach most in Algebra 2, or in Algebra 1, I'm sorry. But if you prefer to use another method, I am not going to make you switch to the X in box. As long as you can factor, we all right. Okay, when we're setting up our X in box, we're going to use the A, B, and C values, and you'll use them anyway. We do our A times C at the top of our X frame and our B at the bottom. So I'm going to take my A times C, my 1 times 8, and that's going to give me 8 at the top. My B of negative 6. And this is where it comes into something like the bell work. We're looking for a pair of numbers that multiplies to be 8 and adds to be negative 6. What pair of numbers will multiply to be 8 and add to be negative 6? Yeah, negative 2 and negative 4. What this is doing is this is figuring out how this middle term splits into 2 different boxes, or if you're factoring by grouping, how that middle term splits into 2 pieces when we go to fill in our box. So we take our x squared from our equation, and our 8 from our equation, this 8 over here. And then the other 2 boxes we fill in with this middle term that's been split into 2 boxes, negative 2x and negative 4x. It does not matter which box the negative 2 or negative 4 go into. It can switch between those 2 diagonal boxes. Questions about that setup? Because it's been a hot minute since we factored. And again, this is going to come up in just about every day of this next chapter. Factoring is super duper important, which is why we're going to spend a whole day remembering how to factor. So please, 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 please ask questions. Because if we can't factor, this next chapter is going to be harder than logs. So we're going to pull our factors in columns and rows. So we're going to see what pieces these two share. So x squared and minus 2x, what do they have in common? X. Different color. Minus 4x and 8, what do they have in common? What am I going to pull from these two? Really close. The 4, I agree, that's the number. Is this going to be a positive 4 or a negative 4? Negative 4. This spot will always have the same sign as this box. 100% of the time, every time. Even if all you can pull out numerically is a 1, they will always have the same sign. Let's do our row here between x squared and minus 4x. What can I pull out here? Just an x. And my bottom row, minus 2x and 8. Close. Minus 2. I can't take an x out. What this does is this right here is one of my factors, and this right here is the other. So writing this in factored form, we get x minus 4 and x minus 2. And this is our answer to the question. Or the answer to the problem. It's that factored trinomial. Question on that one? It's the first factoring we've done in a hot minute. Okay. We're going to do more of these. We're going to practice this the whole way. So as we go, there's going to be less and less written on the page, and you're going to have to write more and more yourself. But that's okay. We'll get through it. Again, we're going to start with finding our A, B, and C. Because we need to take our A times C at the top right here. What is our A value? 1. What's our C?
16.
So what's 1 times C? Or A times C? 16. Whoa, wrong pen. At the bottom goes my B value, which in this case is 8. We're going to find a pair of numbers that multiplies to be 16 and adds to be 8. What pair of numbers will multiply to be 16 and add to be 8? 4 and 4. So when we fill in our box, our x squared goes in the top left. Our 16 from the equation goes into the box. And then we have our 4x and our 4x. Pulling our factors. What comes out of this first column? X. What comes out of the second column? And a 4. First column, or first row, x. Bottom row, 4. When I put these into factors, what operation goes between the x and the 4? What's going to go in between? Plus. I just wanted to check it because we haven't actually talked about it. So we wind up with x plus 4 and x plus 4. What's another way I could write that? Yes. X plus 4 squared. Those two things mean the same thing. I wanted to bring that up because we may see that notation throughout the course of the chapter. And so I wanted to see that those two things are 100% equivalent. Questions on this one? Kiyuki. We'll do 3 together and then we'll talk through 4 and then I'll have a thing for you to do because we have plenty of time. So 3 and 4, we didn't give you the boxes. You're going to have to draw your own. This one is a be super duper careful kind of dealio. If you recognize the pattern, great. You are in excellent shape. If you don't, that's 100% okay. Looking at this one really carefully. What is my A value? 1. What is my B? We don't have one. So what do we put? 0. And what's my C? -4. It's okay for 0 to be a thing. So when we fill in our X frame, we wind up with our A times C being -4 at the top and our B at the bottom being 0. What pair of numbers are going to multiply to make -4 and add to make 0? Not -4 and 4. You're on the right track. -2 and 2. Because they need to add to be 0. -2 and +2. Whenever you have a 0 on the bottom, these two numbers are always going to be the exact same number. Because for them to add to be 0, we have to have a positive and a negative version of the exact same number. And in fact, when your B is 0, they're always going to be the square root of this number up here. But we can build our own box, and you can 100% do it that way. This one is a special pattern that you don't necessarily have to use the box for. Does anyone remember what this pattern is called? It's okay if the answer is no. Let's see what we get and see if it flashes back any phrases. What are we going to get in this first column? What is shared between x squared and 2x? Just an x. How about shared between -2x and -4? -2. Exactly right. Top row, x squared and -2x. X. And bottom row, 2x and -4. Shared here. 2. So when we write this into our factored form, we have x minus 2, x plus 2. This is one of those patterns we talked through, especially last semester. We talked on it a lot during quadratics. This one is a difference of squares. Because x squared is a perfect square and 4 is a perfect square. We can use that to build this thing. One has a minus, one has a plus. You can get from here to here without having to go through your x and box, as long as you remember that pattern. And as we go through this, you're going to hopefully learn that pattern because that's going to come up a fair bit. If not, it totally works to x and box it 100%. It's fine. I want you to try 4. Work through 4, and then we'll talk it through in a minute. So work through 4. Looking good, looking good, looking good. All right. It looks like just about everyone's at the very least to the X box on this one, or to the X on it. So, and they all looked good, where we had our -3 on the top, A times C, and our B on the bottom. What was our pair of numbers that multiplied to be -3 and added to be +2? What'd you guys get? 3 and -1. So we filled in our box and got our factors. What was our factored form? What did we get? What was your answer? X minus 1, X plus 3. We'll start to notice we don't always have to use the box. When your A value is not 1, you do have to use a box. If you notice your A value being 1, it's just these guys. X minus 1 and X plus 3. So there's a couple of shortcuts we're going to be able to take. Because this chapter is not just about factoring. We're going to take our factoring and then do stuff with it. So like it's going to be a thing. But it's super duper important that we remember how to factor. So I handed out while you guys were working on number 4 a answer sheet for the problem trails around the room. It's all factoring. Start somewhere. Factor, 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 factor. Going through the whole thing. Okay, do as much as you can. I know we only have 20 minutes left, but there's not like a homework for tonight. And I would love to get you guys some points and stuff to, you know, hopefully help make up for that test. Because for those of us that didn't do great, it was brutal. For those of us that did all right, it was all right. It was all right. But if you didn't do all right, it tended to be brutal. Okay, if you are interested in retaking that log test, go look at the pink form for what you need to do for retake. Okay, because yeah, it wasn't bad for everybody. But if it was bad, it was real bad. So go ahead and start doing the thing. If you are one of those people that likes to glue notes into your workbook, page 450 has a great page for it, but it's up to you. And we're going to have a quiz on March 22nd, which is the Wednesday before spring break. Okay, go. You have the rest of the period to work on this. Ask questions. I'm here to help.